Good morning to everyone. So today we'll study about ion exchange resin drug delivery system. Okay, so it is a last approach as per your syllabus for CDDS. Okay, so it is also similar like diffusion CDDS and dissolution CDDS. It is also one of the approach. Okay, so here we are using the system is resins. Okay, and which containing the ionic environment. Okay, so what it is exactly we'll study. So it is one of the attractive methods for modified drug delivery system is the use of ion exchange resins as carriers for such system. Okay, so these are the carriers we are using. Okay, complexes between ion exchange resin and drugs are known as ion exchange resonates, which have been used in pharmaceutical formulations for several decades. Okay, so first we are making the complexation. Okay, so nothing but we are going to bind the drug with the ion exchange resin. Okay, so that complex is called as ion exchange resonates. Okay, I'll explain later this one. So exactly what it is. Okay, so ion exchange resins are the water insoluble high molecular weight cross-linked polyelectrolytes. Okay, so resins used are polymers that contain appropriately substituted acidic groups such as carboxylic and sulfonic for cation exchangers or basic groups such as quaternary ammonium group for anion exchangers. Okay, so ion exchange resins have specific properties like available capacity, acid base strength, particle size, porosity and swelling on which the release characteristic of drug resinates are dependent. Okay, so nothing but what are the properties, what is the characteristic of this ion exchange resin means it is a water insoluble. Okay, so when it will be coming to contact with the dissolution fluid, it will not get dissolved. Okay, so just it will absorb the moisture content, so water content, and it is form gel like structure. Okay, so it will swell in nature, that's it. Okay, so it will not soluble in the water, and it is containing normally high molecular weight. So why? Because it is containing polymer chain. Okay, so that's why. And cross-linked polyelectrolytes. So resins used are polymers. So nothing but resins, the different type of polymers we are using. Okay, so in that we are considering the ionic resins. Okay, so it may be anionic or it may be cationic. Okay, so containing appropriately substituted acidic groups such as carboxylic acid and sulfonic acid. Okay, for cation exchangers. For basic groups such as quaternary ammonium and also polyalkyl groups also we are using. So that is for anion exchangers. Okay, and these are some of the properties will be there. I'll explain you in detail later. So the characteristic means you have to write it's a water insoluble and high molecular weight cross-linked. And so what are the colors? An ion exchange resin is exhibited like small bead with a diameter between 1 to 2 millimeter. It's usually white or yellowish color and it is fabricated from an organic polymer substrate backbone. Drug resinates are generally prepared with purified resins and appropriate drugs. Based on nature of ionic species, interchange the ionic exchange process is known as either cationic exchange and anionic exchange. The drug is released from the resinate by exchanging with ions in the GI fluid followed by drug diffusion. So I hope you got. So nothing but, so it will be available in the diameter between 1 to 2 millimeter, and also we can say that it is almost spherical in shape. Okay, so beads we are forming, right? So beads always it will be in a spherical shape. Okay, and the color we can say it is almost white to yellow, white or yellowish color. Okay, and it is having the backbone, so that is polymer substrate. Okay, so normally we are using divinyl benzene polymer or styrene divinyl benzene polymer we are using. So for that backbone, so some of the acidic or basic ion exchange resin will be there. Okay, so for that whole system we are complexing drug molecule. Okay, So next, what are the different properties? So high molecular weight polymeric compound, so cross-linked polymer matrix, cross-linking accomplished by addition of divinyl benzene. The polymer backbone contains the functional groups which identifies the type of ion exchange resin. The functional group is also called as fixed ions. To the fixed ions are attached oppositely charged counter ions. These counter ions are exchangeable with ions of similar charge present in surrounding solution. Thus, these polymers are called an ion exchange resins. Insoluble in common solvents such as water. So nothing but it's having higher molecular weight, the first point, and cross-linking polymer matrix also we can obtain. How we will get cross-linking means, so it contain polymer. So wherever the polymer is going to bind with another resins, so that time, so cross-linking will be occurring. Okay, so polymerization, how it will be occurring means due to the cross-linking. Okay, so how it will be working means we are adding divinyl benzene, so that is one type of polymer chain. Okay, so by adding this divinyl benzene, so cross-linking will be occurring. Okay, the polymer backbone contains the functional group. Okay, so this divinyl benzene chain will be there, right? So we are calling as a polymer backbone. So it containing a different functional group. Okay, and that functional group is a fixed function group. Okay, so if the function group is sulfonic acid or if the function group is carboxylic acid, so that we are saying as a anionic or cationic. So like that depends upon which function group is there. So it will give rise to the which ionic exchange resin. Okay, so that is what, and it's almost insoluble in common solvents such as water. So the same thing will be there. Okay, ion exchange is a reversible process. Okay, due to the presence of high molecular weight water insoluble polymers, the resins are not absorbed by the body and are therefore act as a inert material. Okay, so due to high molecular weight it cannot be absorbed by the water and it cannot dissolve also. It just what act as a inert material. Okay, the most common resins used in formulation are cross-linked polystyrene and cross-linked polymethacrylate polymers. Okay, these are the main polymers. So these are the main resins we are going to use. So this is about introduction part. Okay, so I hope you understood what are the things. Ion exchange resin, it is nothing but, so just it is a properties water insoluble high molecular weight cross-linked polyelectrolytes. Okay, so when complexation between drug and ion exchange resin will be occurring, that is called as ion exchange resinates. Okay, so here spelling mistake will be there. So this is not resonates, it is resinates. Okay, ion exchange resinates. Okay, so after that that resin, it is containing polymer chain. Okay, so polymer chain resins, and in that functional group will be there. So it may be carboxylic acid group, sulfonic acid group, or quaternary ammonium group, or polyalkyl group. Okay, so depends on which functional group will be there. So that will be give us to know that which ionic exchange resin it is, cationic or anionic. Okay, so that is what. And the spherical shape, diameter, color, so that you have to study in this introduction part. Okay, so after that resins are water insoluble materials containing anionic or cationic groups in repeating units on the resin chain. Okay, so a cation exchange resin generally has sulfonic and carboxylic functional groups as an integral part of the resin and an equivalent amount of cationic drug molecules. Okay, so how we will call as a cationic or anionic means, see, if we call it as a cationic exchange resin means that resin complex it should contain sulfonic, either sulfonic acid group or carboxylic acid group. Okay, so that is one part, and it should carry cationic drug molecule. So that's why we will call it as a cationic exchange resin. Why? Because it is having cationic drug molecules which is complexed with the sulfonic or carboxylic functional group of ions. Okay, I hope you understood. Okay, so that is called as cation exchange resin. An anion exchange resin generally has quaternary ammonium groups and polyalkylamine functional groups as an integral part of the resin and an equivalent amount of anionic drug molecules. Okay, so in case of anion exchange resin means it contains anionic drug molecule. So that will be complexed with either quaternary ammonium group chain or polyalkylamine functional group chain. So these are the two concepts, okay? Cationic exchange resin and anionic exchange resin, okay? So in cation exchange resin, cationic drug molecules will be there. For that, oppositely, sulfonic or carboxylic acid functional group chain will be there, polymeric chain, okay? For anionic drug molecules will be there. So that will be complexed with either quaternary ammonium group or polyalkylamine functional group chain. So that's it. I hope you clear. Okay, fine. So next, so further it will be classified as, okay, a cationic exchange resin will be there, right? So that is further classified into strong cation exchangers, weak cationic exchanger. Wait 1 second. Okay, this is better. So that is wrong. Something wrong will be there in that slide. Okay. So whatever the cationic exchange resin will be there, so that is further classified into strongly acidic cation exchangers and weakly acidic cation exchanger. Okay, so two types. And that anionic exchanger resin will be there, right? So that will be further classified into strongly basic anionic exchange resin and weakly basic anionic exchange resins. Okay, so again we will get four types. Okay, so in cationic two types, that is based on acidic medium, and this anionic based on basic medium, strongly and weakly. Okay, so what is this strongly acidic cation exchanger means? Okay, so it contain sulfonic acid group. That's it. Okay, strongly acidic means it contain sulfonic acid group. Weakly acidic means it contain carboxylic acid group. Okay, so only two things will be there, right, in cationic exchangers: sulfonic acid and carboxylic acid. Correct? In strongly acidic means sulfonic acid group will be there. In weakly acidic means carboxylic acid group will be there. Okay, so blur will be there. So this image, sulfonic acid groups attached to a system and divinyl benzene copolymer. So that is called as strongly acidic cationic exchanger. Okay. Weakly acidic cationic exchanger means carboxylic acid groups attached to an acrylic and divinyl benzene copolymer. Okay. Strongly basic anionic exchanger means quaternary ammonium groups attached to styrene and divinyl benzene copolymer. Okay. Weakly basic anion exchanger means polyalkylamine groups attached to a styrene and divinyl benzene copolymer. So this will be different types of ion exchange resin. Mainly two types will be there: cationic and anionic. Okay, under cationic, so depends upon acidic nature, it will be strongly and weakly you will find. Okay, and under the anionic, again strongly basic and weakly basic you will get. Okay, so these are the types. Okay, so these are the structures you can observe. So here you can observe SO3 H group is there. So nothing but sulfonic acid group will be there. So that is strongly acidic cationic exchange resin. Okay, so here you can observe. So repeated sulfonic acid group will be there. Okay, so and this is the polymeric chain. Okay, so that is nothing but polystyrene chain. Okay, so polystyrene chain, so which is containing polystyrene with divinyl benzene, which is containing sulfonic acid group. So that is called as strongly acidic cationic exchange resin. Okay, for this we are going to complex with the drug which is cationic in nature. Okay, and here you can observe, so this is quaternary ammonium anion. For that, so it is attached, so this is polystyrene divinyl benzene chain. Okay, so for that added quaternary ammonium group. Okay, so here also you can observe repeatedly quaternary ammonium group is attached to a divinyl benzene chain, polystyrene divinyl benzene chain. Okay, so this is strongly basic anionic exchange resin, and for this complex again we are going to add anionic drug molecules. Okay, any confusion? I hope you are getting. Okay, so next we'll study about the mechanism. So how we are going to make this ion exchange resin complex? The ion exchange resin system can be designed by binding drug to the resin. Okay, so resin is nothing but it's a polymer. That's it. Okay, and that polymer containing ions. That's it. Okay, so it may be what sulfonic acid group or carboxylic acid group or quaternary ammonium group. So like that. So which functional group it is containing, right? So depends upon that we are going to add drug molecule. That's it. So it should be just oppositely charged. That's it. Okay. So first we are going to design by binding drug to the resin. Okay, so after the formation of drug resin complex, a drug can be released by an ion exchange reaction with the presence of counter ions. Okay, so I'll tell you how we are going to make that first. So just we'll get to know what is the mechanism. Just imagine, so we have formulated ion exchange resin complexed with the drug molecule. Okay, so we have that drug resin complex now. Okay, so when it will be when we are administrated, okay, so what happens, it will reaches to the dissolution fluid, right? So it will contact with the fluid. Okay, so that is bulk in amount, right? So in that fluid also some of the ions will be there. So it may be sodium chloride or HCl will be there. Okay, so different ions will be there, right? Okay, so when it will come into contact with these ions, right, so that time displacement will occur. Okay, so what happens, so whatever the drug molecule will be there, right, so here you can observe, so this resin, it is complexed with the cationic drug molecule. Okay, so this is called as cationic exchange resin. Okay, so here exchangeable part is drug molecule. Okay, so exchangeable part is cationic drug molecule in the first reaction. Okay, so when it will contact with the sodium chloride, here sodium, it is a cationic part, right? It carries positive charge, so it is the cationic part, and the chlorine is the what anionic part which carries the negative charge, right? So this drug is having the exchangeable property. Okay, and it will displace with the sodium ion. Okay, so when this resin and drug complex reaches to the fluid, bulk volume of fluid, okay, so their displacement will occur. So with what means the counter ions will get displaced. Okay, so drug should release means resin should complex with the sodium ion. Okay, then drug can easily release. Okay, see, resin and drug complex will be there in the initial. Okay, so when it will be contact with the fluid, right, so in that fluid, in case sodium chloride ion will be there. Okay, sodium chloride, that ions will be there means resin, it is eagerly what make a complex with the sodium ion, and it will release the drug molecule. Okay, so why it will form a what displacement, why it will occur means it is a very the bond between the resin and the drug molecule, it will be very least. Okay, so very weak bond will be there. Okay, so due to that weak bond, this ions is the resins what we are using, right, it is having the exchangeable property. I hope you understood. See, after the formation of a drug resin complex, a drug can be released by an ion exchange reaction with the presence of counter ions. Here, in the first reaction, counter ion is sodium, which carries the same charge like drug. Drug also carrying positive charge and sodium also carrying positive charge. So that's why drug will be displaced with the sodium ion. Okay, so after this ion exchange reaction, so we will get resin and sodium complex, and the drug will be left as a free molecule and it will start to release. So in practically we have to say means what happens, that beads we are preparing, right? Ion exchange resin and drug molecule complex beads we are preparing. Okay, so that beads we are going to add in a capsules, or we are going to make a granules and punch into as a tablet. So normally we will get in a capsule form only. Okay, so when we are going to administrate that capsule, right, it will release the beads. Okay, so when the beads are contact with the water or fluid, right, so that resin is insoluble in water, right, so it can't solubilize, right, so it will absorb the moisture content and swell in size. Okay, so after this swelling in size, that drug particle will be there, right, so which carrying the charge, so it will search some similar charge ions. Okay, so in case cationic exchange reaction will be there means it will search sodium ion. Okay, so if the anionic part of the drug will be there means it will search chlorine ion. Okay, so like that, so which type of drug will be there, so it will search the same charged ion and it will start to displace. Okay, so then after displacement, so we will get resin and sodium complex and drug start to slowly diffuse out from that gel. Okay, and it will start to diffuse out with that gel and it will start to release the mechanism. Okay, so that is what concept. I hope you understood. In this type of delivery system, the nature of the ionizable groups attached determines the chemical behavior of an ion exchange resin. So here you can observe the reaction resin which is carrying the negative charge, the drug which is carrying positive charge. So first we are initially making the complex, and when it will treated with the similar charged cationic ions, so then resin and that cationic ion will make a complex and this cationic drug will start to release. Okay, so next reaction, the resin is having positive charge and the drug is having negative charge. So first we are making this complex, positive and negative complex. When it will reaches to the fluid, okay, so it will contact with the negative ion. Okay, so which is carrying negative charge, so nothing but chlorine. Okay, so that time resin will complex with the chlorine and drug will start to release. That's it. So don't go deeply, so just get to know what is the terms. That's it, or else you'll get confused. Okay, so just go to the terms, go through the terms and you will get to know what it is. Just opposite and negative things will be there. That's it. Okay, and the factors that affect the selectivity coefficient include type of function group, valency and nature of exchanging ions and nature of non-exchanging ions. Okay, so here exchanging ion is drug and sodium, non-exchanging is chlorine in the first reaction. In the second reaction, exchangeable is drug and chlorine and the non-exchangeable is sodium. So that's it. Okay, so I hope this is enough for today. Next we will study how we are going to formulate this resin complex and what are the different factors and application. Okay, I hope you understood. Any doubt will be there, you just message me. I try to clarify that. Okay, thank you.